Hello, this part of the lesson is about surface finish. Your objectives for this section are: first, differentiate between the various symbols used for surface texture. 2, properly apply surface texture symbols to an engineering drawing. 3, recognize the preferred average roughness values. 4, differentiate between the lay and their definitions. And 5, interpret surface texture values applied to surface texture symbols. Okay, finish marks. Finish marks show up on drawings. This is the first one. This is called a finish mark. It has used to have equal legs, and then this is the standard for it right now. This is an old interpretation of it, and this finish mark means the surface finish is machined or finished as on a rough casting or forging, which means you have to come in there and machine. So there has to be some extra stock there for allowance to be machined. Notice how when we're placing the surface finish symbols to the extension lines here, we place the line, the symbol on the side of the line with the surface itself. And look at the difference between this no here and the good. We'll talk about again that later. Here are some of the ways to interpret surface roughness symbols. Here is your basic. It kind of looks like a check mark. That's the basic surface texture symbol. Surface may be produced by any method except when bar or circle is specified. The second one, when we have the bar here specified in the surface finish symbol, that means the material removal by machining is required. You have to go in there and machine that. And then if you have that bar across there and then there's a number here, that is the material removal allowance. That's how much extra stock is on there to be machined off. Now, if you see a circle in the check mark here, that means no material removal. Material removal is prohibited in this area. And then finally, this is the general surface texture symbol. It's like a check mark again, with this added with this long tail. And we're going to talk about what that means in the next slide. The surface finish symbols, these texture, that comes from ASME specification Y14.36. Some of you use ISO, and it's a little bit different, so I'll talk about that probably in class. Here is how we interpret the basic roughness symbols. Again, this is the ANSI standard. So what we have here is we have our basic surface roughness symbol. This number right here, this represents the roughness height, the arithmetic average. If there's only one number here, that interprets like that's the maximum allowable surface finish. Like in this particular case, the surface finish can't go over this 63 microinches. It can't go over that. There can also be a range. If you specified a number up here on top, then that could be a range. If you had to have the surface finish between a certain range, like say you didn't want it to be too smooth, you could put a range on this. And then these top numbers here on the top of the tail, you got waviness height and then waviness width. Okay, let me talk about waviness a little bit here. And that's what this picture is for. There's two items on this. It's roughness and waviness. Okay, so roughness is kind of like between these ridges here, and then wavy is like more of a gradual change in height here. So waviness height is the difference from the top to the bottom of the waviness, and the waviness width is like the period, if you will, of the waviness. The roughness width then is a little bit different. That is just these tool marks in here, and then the roughness width cutoff is this length right here. I'm going to have to get you a better explanation of that. And then the lay direction, that is the direction of the tool mark. So when we talk about lay, we're going to be talking about the direction of the tool mark. So these ridges here are caused by the machine marks. Those are our roughness. And then the gradual, more gradual, like period, if you will, that's called the waviness. And here is how it's just shown in the symbol, where we have the lay symbol shows up right here, the roughness width cutoff. Now you don't have to have all of these elements in your surface finish. They're not always all applicable, but these are available for you to use. Here's how we apply surface roughness symbols to a drawing. There's a lot of features on here. So what we're saying here is we've got no material removal here. We have a surface finish. This surface finish is applied with a leader line to an extension. This one is applied through a leader line, through an extension line, and this is a machining required. This has a specific value. The 1.6 here, that tells me this is in SI units, in millimeter units. That's because of the preferred sizes. 1.6 is a preferred size. We're going to talk about that in a little bit. One thing I want you to notice about this particular cartoon is that this application seems to contradict our earlier one. It seems to contradict this. This method here says this is good. You have to turn these upside down. Whereas the other slide, we just showed it to be like this. So it's a little bit contradiction. I guess I'm not going to be too picky on that point. I would prefer that this would be on the other side, upside down. But again, since it's okay, whatever we do. Let's talk about lay. Now, lay is the tool marks. And then these are the different symbols used for lay. So in this case, you have lay parallel lines, so that looks like it equals marks. Okay, you can get that with milling, for instance. If you have the symbol X, that gives you cross hatches, like tool marks. And if the lay is just all directions, you put an M in there. If the lay is perpendicular, you put the perpendicular sign in there. Circular, like a turned surface, you could put a C in there, and then R, it's kind of like a spirograph here. And that's how this goes. And the lay symbols, again, the lay symbols would go right here in your surface roughness symbol. And then apply texture values. These are just some examples of these different things, just applications of how to use them. So what I would do is just review this slide, look at each one of these, and then compare it back to this. I would get a view of this. I put this particular cartoon on your objectives so you can see that one. So I would go through this one and make sure you understand each one of these examples. And then finally, these are the preferred sizes. If we're talking about micrometers, okay, that's where you got the 1.2, for instance, was in there. So 1.60, so these are the preferred roughness values in both micrometers, also in micro inches. So if you're doing your drawings in inches, you would use these preferred values for micro inches. If you were doing your drawing in millimeters, you would use the micrometers preferred values for surface roughness. Just for relative scale, an 8 micro inches is pretty much a glass smooth surface. Your general roughed milled surface is probably around a 125. That's just for general comparison. Okay, that is it for surface roughness. Thank you.